There she is. Thank you, Alexa or Siri or whoever you are. Oh, look at that. All right. Am I sharing this time? I love the time that I talked for like
Yes, you
3
are.
minutes and people are like, oh, you're not sharing your screen. I'm like, you're kidding me. Okay, so welcome. Hey, it's April. Some of us, handful of us are in Denver, but welcome to our meetup. As you heard, oh, come on, seriously? There we go. The lady tell us this is recorded and I have just uploaded a couple months worth of things to YouTube, which I had forgotten. So this, hopefully when I remember, will also upload those to YouTube. And the link to that is somewhere in our Slack. If somebody wants to find out that and share it with people, that would be probably a friendly thing to do. I'll do it later as well. Or I could put it in meetup notes too. That'd be good. Anyway, what are we going to do tonight? We'll have a few announcements. We'll have a speaker, opportunity for show and tell, and then Zoom social breakout. So when I say show and tell, what do I mean? It's an opportunity. We just open the floor. If you have problems, questions, side projects, something you discovered, something you're uncertain about, just something of general interest, beam related, we give you that opportunity. Sometimes we do it, sometimes we don't, but it's an opportunity we provide. All right, so the organizers of the Denver Erling Elixir meetup are in no particular order: Jeff, Jeffrey, Dylan, I'm Brett, and Alexandra. And yeah, with very much enthusiasm is Jeffrey. That's good.
Hi.
How do you get hold of us? Well, we post all of our meetings on Meetup to let you know when we're going to get together. We have a presence on the Denver Slack channel, and we have our own Denver Beam Slack, which is more for local things, meetup things, and it sticks around a lot longer than the big Denver channel. So free to invite, free to join.
Posted the inviter to our Slack org in the chat in this.
Oh, very nice. Yeah, thanks for that URL too. That is pretty sweet. All right, a quick word of thanks to our sponsor, Pay It Off, my favorite employer, because they're paying for the Zoom and the meetup fees, which finally we're paying, which is good. Anybody have any general announcements?
No. Just a reminder that MPEX is coming up in May, MPEX Mountain. It's in Salt Lake City, and last I saw, it looked like there were still some tickets available. So
I saw on Twitter they were going to be closing ticket sales, but I don't know.
Okay.
I don't know. You could look at the website, but I'll be there. It'll be good.
I'll throw out there that I'll be there. But announcements I've got. So Smart Logic is hiring Ruby/Elixir senior engineer.
And you're ahead. You're ahead of things. We do hiring in just a minute.
Oh.
I didn't want to shut him down, man.
I don't mind Ruby. I'll just smack people's enthusiasm right down.
Okay.
Yeah, you're doing it wrong.
Wow.
All right, forget I said anything about that.
Okay, hold that thought. We'll get to that in about 3 slides, all right? Okay, so the excitement last week is last month, we had our first in-person / remote meetup in a long time, and it was me and Don. So we had a lovely time, beautiful beer, good dinner. But I'm hoping perhaps maybe next month, people in Denver might be interested in actually showing up in person. So if you are local, is there anybody who would show up if we actually went back to Solomon's clubhouse? So Don, you would go, wouldn't you?
Yeah, for sure.
Yeah, see, okay, all right. Anyway, I may try that. So Solomon said it sounds like it's a thing. So we could do that if we wanted to. So I will throw that open. And we're going to continue to be online because we have met so many great people online. We want to keep that going. So we'll be trying to do some kind of hybrid thing, kind of like I did last month, where most of the meeting will be on Zoom. Speakers will be on Zoom. So speaker can be in Berlin in the middle of night if he's crazy enough to do that. but there will be a couple of us locally gathering for probably pizza and beer like the good old days. Watch this space. All right, now, hey, anybody? I don't know. Anybody have any hiring announcements? Owen?
I was so proud of myself for coming up with something, but yeah. So Smart Logic is hiring a senior Rails and or Elixir senior engineer, and also a product designer, if I remember correctly. So take a look at smartlogic.io, and I believe there's another opening I don't have at the top of my mind, but yeah, so take a look there.
Okay, if you happened to have links to those openings, we would love to put those in our jobs channel on our local Slack, because then I will remember them and people who aren't at the meeting can look them up. So
Right,
that would be super awesome if you can dig those out. We appreciate that.
will do.
Anybody else hiring?
Yeah, we're still definitely hiring at PepsiCo. Yeah, I'll post that in the Slack. And also since we are remote-ish, we have an office. I think our two director level positions have either been either we're close or have offers on, but we're going to start hiring individual contributors in Poland as well. So let alone the people in the United States. So I work on the ecom team. PepsiCo's this huge organization, but ecom is more like startup minded, scrappy, get things kind of done kind of organization. It's fun to work there.
And they use Elixir.
And they use
Who knew?
Elixir, that's for
Who
sure.
knew? That's great.
Yep.
All right, anybody else hiring?
Yeah,
Jeffrey!
but this is more looking for your referrals, I think. Just
Sure.
because it is Europe. So we're looking for somebody who's remote in Europe. We've got a senior position that is somebody who needs to know Elixir, and then we have I think it's either a staff or a principal position of somebody who doesn't have to know Elixir, but has to have some decent other experiences. We're a very fun company to work for. Although admittedly, I can only say now that we only have one core team member working with us. But a bunch of authors, good people, good place to learn, and a career track for individual contributors who don't want to go into management. So, aha.
Most importantly, Jeffrey, would they be able to work with you?
They'd have to probably, yes.
Okay, all right.
Although they're probably safe for the most part because there's only a couple hours of crossover a day with
Right.
Denver and the Europe. So
True.
Yep.
That's fair. All right. Anybody else hiring? Sounds pretty quiet. All right. Anybody looking who'd like to pitch? All right. If you are looking, we got some links. Hopefully someone can copy those links over into the Slack channel so that will exist past this Zoom, which would be nice. All right. It's the monthly plea for speakers. So Anton, thank you very much for volunteering. We are always happy to have people, no matter where you are, what your time zone is. We just ask that it be Beam related. It can be a intro talk. It can be an advanced topic, whatever you want to do. We will probably be very happy to hear from you, and we'll help you out in any way we can to put your talk together. If you want to practice, we are there for you. Also, if you want to dry run for a conference, we are,
it's a good place to workshop talks.
Yep, that's just like Todd did last time, and he got a lot of feedback, and hopefully I haven't seen his final cut. Yeah, well, you get what you pay for. So there you go. Anyway, if you would like to do that, please reach out to us. Slack's probably the best place, but you could probably reach us on Meetup too if you are interested in sharing your experiences with us. And right at the moment, we're pretty wide open in the speaker field for the rest of the year. So would love it if someone would have some time. Okay, what else do we have? Oh, hey, it's our star, our speaker, Anton. I'm not even going to pretend to pronounce your last name, but he is going to be talking about the application layer framework. not ALF, as Don was saying. Oh no, it's the application layer framework. So
Willie.
I have no idea what that is. So Anton, I am going to stop sharing and hand this over to you and let you introduce yourself and then enlighten us.
Thank you, Brett. Yeah, thank you for having me. Actually, there are not so many Elixir meetups in the world, I would say.
Really?
So last time I presented in Sydney Elixir meetup, because in Berlin we kind of have Elixir meetup, but it's like four months or more inactive. So yeah, it's really hard. So that's great that in Derwent you guys do this.
So I just want to throw out, that's because of Brett. He's put a lot of energy, especially once the pandemic kicked in. He is the reason this is still going. So
I get help. I fully admit that.
You do, but you are still the driver and do the lion's share. So thank you.
Happy to do it.
Okay, then. So can you see my screen, guys?
We can.
Cool, then. Okay, I did a full screen now. So yeah, let's go. The last name pronunciation is Mishchuk, Anton Mishchuk, but never mind. So yeah, I'm software engineer. Currently, I work for Klockner.ai company that is based in Berlin. And yeah, we are hiring Elixir engineers if you want to move to Berlin, guys.
Maybe.
Please. Yeah, you can find me on GitHub, on Medium, read my articles, please. And yeah, I wanted to start it from sad news. I'm pretty sure that you're aware about the hard situation in my country. So yeah, it's kind of, I would say, world-scale tragedy. More than 10 people left their homes, like more than 3 million now are here in Europe. You know that Mariupol is kind of destroyed city, and maybe you have heard about latest news about Bucha town. So yeah, it's terrible. So yeah, if you can help, please, first of all, push your politicians. I think that like with hard sanctions and strong weapons, I think that my country can easily win this war. And you can also donate. I kind of posted here a couple of links to like most well-known volunteer organization in my country. And yeah, of course, if you have refugees from Ukraine in your country, please help them. And let's talk about Elixir and talk about application flow-based application layer framework. So what they talk about, actually, it starts from flow-based programming. A few short introduction about what it is, then a bit more about application layer, because I remember when I started kind of pitching my project, I kind of realized that many people doesn't really understand what the application layer is. So yeah, I would like to say a couple of words about that. And at the end, actually about the framework, what it is. So let's start from flow-based programming. Maybe some of, yeah, guys, and please, I have a chat opened here. So if you have a question, please interrupt me and I'll answer your questions. So flow-based programming. The idea basically is quite old, guys. It's the idea from late 60s. And the inventor of this approach is John Paul Morrison, quite an old guy, but this guy is still active as a programmer. And if you join flow-based programming channel in Discord, you can really discuss with him different aspects and see how actually the idea evolves not only in Elixir, but in many programming language. languages like JavaScript, Java, C++, etc. And this guy actively support all these projects. So what's the idea behind the flow-based programming? Idea is quite simple, actually. Idea is to present our programs as a sequential processing of data, like a data processing factory. And there is a screenshot from book of J. Paul Morrison. You see like a conveyor with bottles. First step is a filler, then a capper, then a labeler. So a bottle is a kind of data packet or data that just go through different stages, and at the end you have a ready product. So basically the idea, yes, as described, just to process data through different stages, just to create a separate components, so-called, and data packets or data or IP packets, information packets, go through these components, and each component transforms data in some way and pass this data packet to the next component. The classical problem that can be easily solved with this approach, but cannot be easily solved with classical conventional programming, is so-called telegram program. And when you have a stream of words and you have to format them into strings of defined lengths, for example. But actually, I would say that any more or less complex application can be designed in a way of sequential transformation of data. And actually what we have in functional programming, we actually transform data through functions. So this approach should be easily understandable for us, for Elixir developers, so for people from functional programming world. There are many of implementation of this approach, actually. There is a very popular implementation, NoFlow.js in JavaScript. There are also implementation in Java. But John Paul Morrison defines like classical flow-based programming with flow-based programming inspired systems. And actually, the main attribute of classical flow-based programming is that each component executed absolutely independently from other components. So it should be kind of true parallelism or asynchronism. Also, classical flow-based programming should support kind of back pressure in a sense that the flow of data should be controlled, so no of the component is overflowed by the data. And multiple input ports is kind of not really important for us. But yeah, so most of the flow-based programming inspired system are not like true flow-based programming. For example, in JavaScript, you know that like the engine behind JavaScript is not really parallelized, or synchronous, but not parallelized. So we can simulate this approach in some sense, but there is no true parallelism behind it. But in Elixir, we can do this. Okay. Any questions about flow-based programming? I think you will see like details later, so I think it might be easier. About application layer. So what is application layer? Let's kind of mention classics. Eric Evans, domain-driven design. Again, this classical separation between classical layered architecture, when we divide our application into 4 layers, like infrastructure below, then domains and application and user interface. We as backend engineers usually work with 2 layers in the middle, with domain layer and application layer. And domain layer is actually where our business logic is. And application layer is just a thin layer that as mentioned on this slide, that defines the jobs the software is supposed to do and directs the expressive domain object to work out of problems. Yeah, so basically in a good written program, we can see like entities, let's say modules and functions that are responsible for actual business logic. And somewhere on a high level, we see this scene application layer that just call for each like use case or each feature in our program, just call in some sequence this domain logic step by step, or maybe in some parallel steps, doesn't matter. And to illustrate what is, and actually the problem, I would say, the big problem in software engineering, that usually because we write this application domain layer in the same language, actually, we usually don't care a lot about this separation between domain and application layer, and usually we kind of have a bit messy code when it's hard to see where is actually the domain and where is application layer. And as example, I want to show you a tree. This is a so-called function called tree. It's an artificial example, but it's really close to one of the flow we have in our or had in our product before the refactoring. So what you can see here, it's kind of a function called tree. So one function calls another, then another, then another. So the entry point is a storage. Where is my cursor? Sorry. Okay, for some reason I cannot see my cursor, but never mind. On the top, you can see like entry point, storage, storage sync folders, and identifier of the folder passed to this function. Then this function calls get credential function. This function calls sync folders function. Again, this sync function folders function call another set of functions and handle response. Insert folders and files, and you see again many functional calls. So you see this quite complicated tree structure with many functions that are responsible for many different entities. In a green, you can see in green circles or ellipses, you can see like data that this logic work with. So you can see credentials, API response, data structure, customer data structure, folders, etc. So it's quite difficult, and you know that most of the function, lots of the function are in different modules responsible for one part of the logic or for another one. So when you go through this code, you actually can't see forest for the trees. You just see that one function calls another, but it's really hard to figure out what functions are low-level ones and what are really functions responsible for kind of meaningful logic. That is a kind of a good example of code where application and domain layer are mixed. So there is no clear distinction between application and domain layer. But actually, what is the story? In order to kind of extract this application layer, one should think about what is the story that this code wanna present. And the story is actually quite simple. First in this code, let me return a bit back. First in this code, we have to get credentials for the folder, then sync, then fetch data from the folder, then insert folders data into database, then save files into separate storage, and then flag these folders on remote storage as done, it's already fetched. So this is the story, and this story should be in a good code, should be put in application layer. So it should be defined on a very low level and should be explicit in order so any developer can easily understand what is going on in the code on a very high level. And in Elixir, we have a great with structure. So one of the suggested refactoring is just to tell this story in the code, yeah, and introduce like separate modules with separate functions that will define this logic on a very high level. And you see that if we refactor this code and put this high level logic into this statement, everyone becomes really clear. You can see all the steps that our program goes through. First, we get credentials, then fetch folders, then insert folders, save files, flag folders. And with functional programming, it's easy to understand because you see the function and you see just data that pass through these functions step by step. And if we try to visualize this code, we in some sense kind of flatten the tree. These weird structures that were before just flattened, and on the top you can see kind of this explicit application layer that is just a sequential call of high-level functions. And somewhere below you can see this like domain layer implementation that maybe you don't even care about when you explore code first time. Yeah, and I really like this Eric Evans' approach of with ubiquitous language, like linguistic approach to the code. And I would say that in explicit, when you explicitly define this application layer, you then on domain layer you have kind of words and phrases like basic actions that your logic can do, like fetch folders, like insert folders, save files, etc., like implementation of all these basic words and phrases. But on application layer, you kind of have story of your program or like sentences composed from these basic words and phrases. And also in functional approach, we can in functional approach with this clear separation between application and domain layer, you also can see that this basic data structure that defined in our programs, they are also kind of visible and defined on high level. So in that sense, you kind of see all the data that are processed in your application on a high level, yeah, and also all the functions that are responsible for processing this data. So yeah, and one small step is left to MVP. I think that you kind of suspect what is the next step. So when we explicitly present program, explicitly define this application layer, it's really simple now to make this step asynchronous and to kind of invent a different, I would say, even language for presenting this application layer. That is basically the idea behind the framework, is just to give a tool to put these well-defined high-level functions, to put them into asynchronous parallel components and execute them in a asynchronous manner to have like fully data-driven approach. Okay, but before we go to the framework itself, let's again mention this ubiquitous language that Eric Evans introduced in his book. That basically this application layer, okay, it's not Eric Evans, it's kind of my statement. This application layer is in some sense a source of this ubiquitous language, because an application layer you have a high level business logic and function and data structures that you operate on this high level are very similar to words and phrases that product managers actually use when defining requirements for our program. Yeah, so when you want to explain your product manager what your program does, you usually kind of explain this on a very high level. So first we get data, we get credentials from database, then we fetch folders, then we store these folders, then we save files, etc., etc. So this high level logic or application layer is a source of ubiquitous language that you use between software engineers and product manager. That is why this layer is really important, and inventing a different approach from this layer is kind of force us to think carefully about this high level logic and this ubiquitous language. Okay, so about the framework. What we have in Erlang and Elixir is a really great actor model. You know that in Erlang we have process as a basic entity. We also have a more complicated element, how to say, okay, let's put it like element or component in a language component like gen server. Basically, it's a process, but with some life cycle control that we can create them, we can supervise them. Yeah, so like process with more functionality, and also we have like well-defined synchronous asynchronous API for communicating between the servers. And even more, in Elixir, we have a great library that called GenStage library. I'm pretty sure that you have heard about this library. Maybe you heard about Broadway project or other or Flow project in Elixir that uses this GenStage library. So basically, GenStage library is a next GenStage is the next step after GenServer. Except this lifecycle control and synchronous API, GenStage also have a mechanism of subscription. So you can subscribe one process, one GenStage to another, like define this define topology of communication between these processes. And also in GenStage, we have this back pressure mechanism. So basically, data are not pushing from one process to another, but data kind of asking one process from another. So there is never kind of overflow of the process, because process get other data or other messages only when it's ready actually to process these messages. So with this GenStage library, it becomes really simple to implement this flow-based programming approach that I mentioned at the very beginning. And that's actually the idea of ALF, to easily create these pipelines of components to present your high-level business logic. Excuse me. So what is ALF? ALF actually is a set of abstraction, flow control abstractions, which allows you to run program following flow-based programming approach. Basically, it's a simple DSL for building these pipelines. There's a functions like that allows you to actually build them in runtime and pass data through these pipelines. And also as a part of a project, I kind of created in some sense visual language for designing pipelines, quite a beautiful icons you will see later. And also currently I'm working on a tool for monitoring of these pipelines. It's a draft variant for now, but I'll show you what I have currently. So the interface is quite simple. On this slide, you can see an example of defining simple pipeline that does just 3 operations, adds 1, multiply the number by 2, and then minus 3, just an example. And you see that basic construction is this components module variable. So first of all, you use this ALF DSL. And when you use ALF DSL, you have this stage macros that allows to define these components. So you just define components and send function names to these stage macros. And when you run this pipeline under the hood, it will create something like that. So there is an ALF supervisor, like main supervisor, that supervises all the entities in runtime. each pipeline has a special process pipeline manager that actually builds this pipeline and also send data to this pipeline. And below you see like these 5 gen stages that created when you run the program. So basically it's 3 stages in the middle, stages created for your functions, for add 1, multiply 2, and bind to 3, and also 2 more stages like producer and consumer. The producer just push data to this pipeline, and consumer consume data from this pipeline. So that is basically what ALF does, and works. The interface is quite simple. So in order to run pipeline, you just use ALF manager and ALF manager start function and just pass pipeline module as an argument to this function. And the main interface, like the core interface of the pipeline, is streaming interface. So when you stream data, this stream2 function actually returns Elixir stream. So we need to cast this stream to list in order to see the result. And you see that the interface is quite simple. So we just pass this set of events into the pipeline and then get results. So what are the components currently available in ALF? The set is not so big, and actually I'm not sure that it should be big, because I think that these components is more than enough to build complex application. And you can find actually one application in my GitHub profile, tic-tac-toe, a game implemented in this style. So for me, for implementing this game, it is more than enough. So basically, the main component is just stage. It's a component where one put their business logic. Yeah, so as was defined before, like stage is your main component when you define this logic. Also, producer consumers are kind of just components that created automatically for the pipeline. The next component, switch, component that allows you to conditionally route packet into one or another pipeline, one or another route. So you can create like conditional branching. So you can have a quite complex pipeline where on some condition, data packet should go either on one path or to another path. The next component is a clone component. Mostly clone, the idea behind the clone is to do background actions. So you can just on some stage you can clone data packet, and one packet goes to the main line and another copy will go to the another line. Go to and go to points components, special cases for defining like conditional go to. What is the reason behind this go to and go to point? You know that in classic flow-based programming, when you define your program, you can connect components like in any way. So in general, like mathematically saying, it's a graph. So you can have different components and they can be connected in a different way, and so you have like mathematical graph. But with ALF approach and with Gen stage, there is no possibility to have graph. There is only possibility to have a tree, because you can just only subscribe the next stage to the stage before this stage. So you can actually have only like tree-like structure, not like graph. And in order to generalize this, I introduce this go to and go to point. So it's kind of when you have tree structure, but you have this go to statement, you in general you can present kind of any graph. That is the reason behind go to. And yeah, I heard lots of that go to. You know that go to is a really bad practice. How that go to it's a bad thing. But I have an argument against that, because you know we don't like go to, or we hate go to in old school languages like C, for example, yeah, or I don't know, yeah, in C, in Pascal, like these old languages. And the problem with Go2 in these languages is that when you go to somewhere, you kind of go to completely different universe, completely different functions and completely different data. But in flow-based approach, you kind of have logic that is built around your data packet. So when you send packet somewhere else into the pipeline, yes, you kind of send it to another function in some sense, but you still have this data packet. So you kind of moving not to another universe, but at least you have the same component. So I would say that Go2 may be very useful thing for developing, yeah, and of course the idea of generalizing. So one can present any arbitrary graph with tree structure plus Go2. Okay, and few more components. That end component, just that end. When you, for example, when you use clone and you need to do some operation, and then you kind of don't need any result of this background operation, you can just put this that end component, and that's it. You never see this this data packet again. Plug and unplug components, they are also quite internal ones. ALF allows you to compose big pipeline from smaller ones. So you can define smaller pipelines and then compose them together, plug them together and create a big pipeline. And this plug and unplug allows you to kind of to transform data before they go to another pipeline. And two more components, decomposer and recomposer. Decomposer allows you to split one data packet into several ones, and the recomposer do the opposite. You can kind of accumulate different components and then produce one component as a result of this accumulation. Okay, so here on this slide, you can see one pipeline from this tic-tac-toe game that I just mentioned. And I kind of use this buzz phrase, I would say, design, coding, and runtime observability when I'm promoting this ALF project. So basically, when you design your program, you kind of use these basic blocks and just kind of thinking about what my program will do. And for example, this user enters component, when backend has a request from client, when user kind of first enters the game or refreshes the browser. So okay, first I validate the input, of course, then I check if authentication token present. Okay, if there is a token, I go to this upper line. Oh, I found my cursor finally. Then I first I find user by tokens, then I find active game, then I find waiting game if there is no game. If there is a game, you see that go to just prepare game data and send it to client. If no token, first I try to find user with name, then create user, then again find free game. There is conditional branching, etc., etc. So I'm kind of designing from this component. When I code this component, I also see this tree structure in my code. When I define these components module variable, sorry, I don't have example here, but I'll show later. When I define this pipeline in my code, I also kind of see this tree in some way, because in my components module variable, I see these components one after another. So kind of in a short list of code, I can see the same kind of tree structure. And of course, in runtime, when I run this program, I actually have in runtime all these components. Each component has a special gen stage that evaluate code inside. And on this slide, you can actually see the whole tic-tac-toe game. So you can see that there are several pipelines. Basically, user enters on the top, game info, then user moves, and you can even see that user moves reuse this game move pipeline here in the center. You can, again, my cursor. Sorry, guys. Yeah, game move pipeline, user cancels game, so several pipelines, but you actually can see the whole application on one kind of sheet of paper. That is actually the basic idea behind this approach, and why I really like this flow-based programming, because you can define these components. These components are just a graph or a tree of components, and you kind of actually can see the whole application in a very compact in a very compact screen or sheet of paper. Because I think that it's really important, because when you, for example, ask your colleague or friend, could you please write what your program actually does? And it's kind of impossible task for a software engineer to actually illustrate in some way what is going on in the application. But with this approach, you can kind of illustrate this, and you can also discuss this application with your product manager, with business guys. You can kind of sit together and explain, okay, in this component, we check in if game is active. Maybe after that stage, we can also check, I don't know, some specific stuff. And then if not, we can move to these components or something like that. So this is kind of ubiquitous language on top of that. Okay, and killer feature. What can be a killer feature of this framework? First of all, is a visualization, as we discussed. Yeah, so it's really easy to visualize your program. The next feature, monitoring and logging. Again, we have independent stages, and we can easily detect the fact that data packet comes into the component, and the fact that data packet come out from the component. So it's really easy to monitor and to see how data are transformed on every stage in your application. And the next killer feature that might be implemented a bit later, auto-scaling. So currently in ALF, you can define how many copies of each stage will be present in your program. Because imagine situation, like really simple situation, when you have several components, and imagine one of them working with database. Of course, working with database is much slower operations than doing like some calculation. So if you have one component for interacting with database, this component might be really slow, and all the pipeline will be slow. And ALF currently allows you to specify how many copies of each component will be in your program. So you can create like 10 components that will work with database. So when data goes through pipeline, these data packets will be distributed between these 10. And like in general, average time of working with database will be much lower. And the idea, like together with this monitoring, when we can detect these facts that data passes through every component, we can actually check how much time it took in some component, and kind of dynamically scale add some components or reduce amount of or reduce the number of components on some stage. Yeah, and let me now show you something. So ALF monitor demo. Let me, okay, I'm still sharing. I'm exiting full screen mode. And let me show you the code a bit. So yeah, first of all, let me show you this tic-tac-toe game, because I mentioned that it's also coding time observability, but didn't show this observability in the code. So can you see my screen? Yes, still.
Yep.
Pipeline. So for example, the pipelines that were illustrated before is user enters pipeline. And you see, let me close all these. Yeah, and you see here is pipeline defined in the code. You see like components, and you can see like this tree in your code. So first stage, validate input, then there will be a switch. If token present, if yes, then these stages will be implemented. If no, then these stages will be executed. Then it goes to the find free game stage, then again switch. If there is free game, you will see this, you will go to this branch or this branch. If there is no free game, you will go to create new game stage. And finally, you will have a prepare game data stage. So basically what you see in design time, you can also kind of can see in coding time and of course in real time. And let me show how a really cool example of how ALF monitor is designed to work. It's a draft variant now, but it's really interesting what is possible with Erlang and Elixir. Okay, so I have a small application, just Hello ALF, just to demonstrate just as an example. This application actually have two pipelines. One pipeline, just simple one, add one and multiply two. And another pipeline is bubble sorting implemented in flow-based programming. There is a bit more stages. So first of build struct, go to point, find max element, update new list. So there are a bit stages. And there is my console. And what I'm doing right now, I'm kind of running this application, and the application actually just run these pipelines after each second. So you see the simple gen server just schedule work after 1 second, and in handle info work you see that first one pipeline is called with one, and then another pipeline bubble sort called with another set of data, just to demonstrate this. And I run this application, and you see that I specified node name. Yeah, it works. So you see that inputs of sorting array inspecting, and also this add one and multiply by two, that it works. And what I do here in another tab, I just connecting remotely to this node. And what it does behind the scene, actually, it connects to the working application. Then it fetches all the pipeline data from this working application. Then it kind of have this graph and send it to front end and illustrate it. You will see this. And also this application registers telemetry events inside initial application. So this remotely connected application can react on telemetry events that are present in a working application. And these telemetry events are just simple ones. When data packet enters a component, there is an event, and when data packet leaves a component, there's a telemetry event. So when I connect to it and open my browser, yeah, you can see that this graph structure, so you can actually see the graph of your working application. And also as a reaction to an event, I just add this simple blinking for now, but this is kind of a real-time monitoring of things.
Sorry, we can't see
We
your
don't see that.
Sorry, guys. Sorry. Yes. So, yeah.
Oh, that's cool.
Yeah, I use a simple JS library or something for illustrating. What does it call that? Let me check. Yeah, JS library for illustrating graph structure. So you can see like the first pipeline. You see that there are two components of add one. As I mentioned before, you can specify how many components will evaluate on each step. And if we take a look to this pipeline, you'll see that there is a count 2 here. And you can see these two components in visualization. And also for another pipeline, there are 2 updates new list components and 3 rebuild list components. So you can see the visualization and you can see the reaction on every telemetry event that is generated in working application. Yeah, so yeah, and the idea is to, of course, to improve this, to illustrate not just simple rectangles, but these beautiful pictograms that I wrote, and also kind of possibilities are kind of really great here because, for example, you can implement something like checking 10 latest data packets that pass through every component, and just to debug like in real time what is going on. Or you can, for example, detect some errors and check what was wrong in some components. Or you can easily put like telemetry information here. So how much time it took in data packet lift or pause in each component, kind of tune your program. So that's the idea behind this ALF monitor, and this kind of idea of observability, to see everything in your application. Okay, and one more slide left. One more slide left. Again, why framework? It's a philosophical slide, like to have a great philosophical ending. So why do we need framework for application layer? So the philosophical idea is the following. So as I mentioned before, currently we as a backend engineer are mostly focused on domain and application layer. Why so? Before that, remember these old good times when we worked, for example, with Ruby on Rails first versions or something, when we did like everything from infrastructure level to user interface level. We did everything. But again, when applications become more complex, we kind of delegate work to other engineers. Yeah. So currently we kind of delegate this infrastructure layer in some sense to DevOps and also to libraries. Yeah. So like we have, for example, Ecto library. Ecto library, it's kind of in some sense framework for working with infrastructure layers. So for us, database is kind of infrastructure. The same on the top level, on user interface level. We delegate this interface layer to different language. I'm talking about web development mostly. We delegate it to JavaScript guys with their own frameworks. Yeah, so we're trying to distinguish this. And now we have two layers: domain layer and application layer. And as I mentioned before, that the problem why we have these weird applications sometimes is that because we use the same language, Elixir, let's say, both for domain and application layer. And it's really kind of hard to distinguish things when you have the same way of presentation, the same language. So that is the idea that let's then define a bit different language for application layer. And in that way, we kind of will do this distinction between domain application layer. And another statement on this slide that there is no framework possible for domain layer, because you know that all these frameworks that we use, like Rails, Phoenix, etc., they are quite good when we starting our application, but then logic become a bit more complex, we kind of get rid of these frameworks and start to hate them. That's because kind of business problems are so different and approaches are so different that so there is, I would say, it's not possible to invent some framework that will suit any business needs. But with application layer, I would say it's possible because on a higher level, our applications are really simple. On a very high level, our application just does some sequence of operation. First application does this, then this, then this, and this. So on a high level, we kind of can frameworkize this logic, and that is I call this framework and framework for application layer. And flow-based programming is a kind of different approach for doing things that it's not really different from a functional programming approach that we used to use before, but it allows to do many other cool things. Like I mentioned, great design capabilities, great monitoring, great illustration, infinite parallelism, etc., etc. That's it, guys.
Well, thank you. That was really very interesting. Can we open the floor to questions?
Sure.
All right. Does anyone have questions for Anton?
I've got one actually comment I'll start with and a question. One that in your previous slide there, I do live view stuff. So rather than that top layer being delegated to JavaScript, that's also then in the same language. It's Elixir using live view for the interface layer. But I would argue that it's still, even if I'm the same person doing the UI in live view, doing the application layer and doing domain logic, core object, the business logic, that I still want my code organized in these layers. Things compose better. You can build up. It just allows one thing to be built on top of the other. So that I just want to say that as a comment. And then my other question is on some of your stages, they had a little circle with an X in it. What did that nomenclature mean?
Mm-hmm. Yeah, let me maybe show mirror board when I design it. So the idea behind these circles with crosses, actually in ALF, let's put it differently. So sometimes it's useful to stop the logic, stop the logic after some step and not execute other steps. Yeah, and so for example, if everything is done, you don't need to go through other stages, and you can just send it, pack it back straightforward to the consumer. And actually in ALF, there is a done also function that appears when you use ALF DSL. And what this done does, it just kind of set this package back straightforward to the consumer. And this process is kind of, I'm trying to explain people who read this, that on some stages, there will be some work that is done quickly. So it's in some sense, it's a error, but it's kind of control error. So for example, here, when you find user by token, you're trying to find user, but if you cannot find the user, it's the wrong token, you don't need to do any other action. You should just put the error response to the client, and that is why I use done here. And this cross means that on some steps, you just send everything to the end. Just small hint for people who try to read this diagram.
That makes sense. So it's some condition has to be met in order for this pipeline to continue at some point.
Yeah, it means that somewhere inside the logic of this find user component, there is a inside this component there is a logic that can stop the execution of pipeline earlier. So you cannot see packets go further through this pipeline, and they will be sent directly to the consumer.
All right, that helps. Thank you.
All right. Is this something you imagine being useful for every application, every Elixir application, or is there like a specific type or like set of applications that you have in mind for ALF framework?
I'm pretty sure, Owen, that any application can be written this style. So basically, what I did, I implemented just a tic-tac-toe game. It's okay. It's kind of multiplayer online tic-tac-toe game, so many clients can join and play together. But again, it's kind of quite a simple conventional application, and it's just about kind of extracting these, explicitly defining these high-level steps. And I would say that for any application, you can define the high-level steps. But another question is how deep should you go defining these steps? Yeah, should you kind of define a step for every database transaction, or maybe you can combine many database transactions into one components? It's kind of up to you as a designer of software. So you kind of, when you're splitting the domain and application layer, you should reason about what should be on this top layer, how many information, how much information you want to present on this top layer. But I'm pretty sure that every application can be written in this style.
Cool. Thanks.
Lee, do you have a question?
Yes, did I do Zoom right? I'm bad at Zoom. I'm sorry.
Yeah, that's great.
Right.
Amazing.
All right. Anton, I really like this. I'm still processing bits and pieces of it because I'm working on a product where we kind of have articulation of workflows as graphs. And I was just wondering, I might have missed it because my cat was clawing at me and I had to feed him. But what I was thinking of, when you said in the slide, this is a great way of talking to product development and engineering. And this is a very engineering focused graph right now, like set token and that sort of thing. Have you, or is there any future, being able to absorb a graph by let's say libgraph or something, and then trying to spec out how maybe product is thinking about the workflows and stuff like that as a communication layer? Or there's something to this effect? Have you thought about this? I'm not asking.
Do you mean that?
I can give it a direct example. So let us assume my product has some features are turned off if you don't have some stuff in your account, right? We've been drawing these out via graphs, like just standard .viz graphs type thing. And these could easily be articulated as some sort of code stubs in the background, but the way our application is designed doesn't really fit that. And I'm just kind of slowly slotting in how ALF would think about it. And there's probably a way for me to bridge that gap in the communication between product people that have been thinking about how we navigate a user through the app versus the actual nuts and bolts of this. Have you done that type of thing with a product person before, or advice or anything like that?
Certainly, I didn't get actually your question. You mean?
Well, I just mean so there's a slide where you're just
could this
hey,
be perhaps useful as for that application? Is that your question?
Well, it's more as a communication layer between product and engineering.
Right, kind of the ubiquitous language, right?
Yeah, the ubiquitous language part. This is what I'm focused on at the moment. Sorry.
Yeah. So basically, I would say that when you design the new application, you kind of should sit together with the product manager and try to draw these components and build these pipelines and they should be both meaningful for you as an engineer and for product manager also. So it depends how deep you go to the technical details, but I would say the product manager are kind of pretty aware about some technical details about like saving something to database, calling external APIs. They understand these things. So you can kind of find this common language between what products understand, what you understand, and build these components, build these pipelines, design these pipelines in a way that understandable for both of you. And then you can, and then you start to implement actual code behind each component. So I would say it's possible. So basically, you as engineer have some knowledge of product, of business, and product guys also have some knowledge of our engineering stuff. So I'm pretty sure that we can find common language.
Oh, excellent. Yeah, thank you.
Great. Other questions? No. Awesome. Well, Anton, thanks again for staying up in the middle of the night. We're glad that you're able to make it. We understand quite how difficult life is for you now. So we're glad that you were able to make it happen. So thanks again for that. Does anyone have anything that he or she would like to share?
I have a question for the audience.
Oh, okay.
Specifically, has anyone worked with Unix sockets with a Beam application? I have an idea.
Really, could you turn the volume down a little bit there, Roland?
Has
I don't know
anyone
how to do that.
Unix sockets with a Beam application? I have an idea of communicating between a quick activating command line application and a long running Elixir server, a la Emacs and Emacs client. But I've never worked with Unix sockets with Beam before, so I don't know how to listen or communicate on that. Anyone has examples or literature that I can read?
If I remember correctly, I think Phoenix does support the use of Unix sockets. I might be.
Who's someone's very quiet. I can't say. Oh, is it Chris? Is that you?
It's
Got
the opposite.
volume
Yeah,
issues
it's the
here.
opposite issue.
Yeah, I know. Okay.
Yeah.
Roland,
So,
if you could share your microphone with Chris, that would be super helpful.
He was saying that Phoenix has some, or Cowboy more accurately, has some support of Unix sockets.
Yep. If I recall, I don't think it's that odd. Why would you want to use Unix sockets instead of just throwing it off as a process and then having like a pipe back and forth? I mean, not a pipe, but like using standard in and standard out of the child process instead of doing like full blown.
That's it.
Like Unix socketry.
So I haven't designed anything like this, so I don't know.
Oh, okay, cool. So you're unfamiliar with the design. So that's totally okay. That's totally okay. A starting point might be to just have the child process. You get the file descriptor for in and out, and that's how you communicate with it. I want to say that we even have an easy way of handling this through either what was it called? There's like process in Elixir, and then there's like a helper that I think starts with a G. Porcelain, maybe? I might be misremembering, but there's a nice helper for doing this sort of stuff from Elixir.
Oh, and it's porcelain.
Yeah.
You can remember that joke because it's not plumbing, it's porcelain, and it flushes the message box toilet.
Okay.
So that might be an easy starting point. Unix Unix sockets are kind of a faster-ish, in some ways, drop-in replacement for like TCP, that sort of thing. But for like just a spike, I would just try like Porcelain or the moral equivalent.
Right. Also, Erlang offers Gen TCP. I haven't used that in Anger, but I know it exists. So
I've only used it in Anger.
Gen TCP. A nice little trip.
Cool. Hopefully that's helpful.
Also, just to throw out the direct answer to the question too, I would agree with think through the higher level layer first, but OTP does expose socket, and typically I've used that for either TCP or UDP for having to go really low level, typically for embedded stuff. I haven't done a Unix socket for it before, but I believe if you pass it the Atom local, if you look that up in the OTP docs, I think that opens a Unix socket for you.
Handy.
Link is in the thing. You set domain to local.
All right.
Also, you could also check out port. I don't know if that has been mentioned or not. I'll drop a link to that as well.
Yeah, that was actually my first thought too, but it specifically depends on the application and whether or not you got the ability to do something on the other side, the receiving side, right?
Yeah, cool. Good suggestions. Anyone else have questions, things I want to share?
I have a dumb thing I learned on the weekend.
Hey, dumb things are good.
Those are great. Yeah.
Okay, well, just background at work. So we have an Elixir channel at work because everyone likes sharing and doing things, and we just want to chat. And one of the younger folk at our office asked, "Hey, when do I use for and when do I use enum?" And then there was an example, and the engineering question, who I will not point out, was like, I like enum map better because it's clearly easier to read. And then I was looking at it, and to be clear, I have some background in Erlang, and I looked at it like, I kind of like the for syntax a little better. And then there was a long discussion, which was fun. And it was actually interesting. It was nice to see everyone's views and all of that. But I was chatting with another person I work with, but in the evening, and I was mentioning it. Yeah, and I felt proud of myself because the performance doesn't really matter there, and for is a lot faster. And then he's like, "No, it's not." I'm like, "Yes, maybe." And Jeffrey knows because he's going to find out. There's a spoiler at the end of this, which is I was wrong. The short version, enum map is equally fast when you shove a list through it. But my defense of that was for was a BIF, right? So Chris here, who has the soft mic issue, gave a talk on benchmarking things, and I happened to remember. It's like, hey, maybe I can just implement this 3 times. And there's a reason why I'm doing 3, and I'll explain in a second, and just benchmark it. All turned out to be the same, approximately. And then I was like, okay, what's going on? And for everyone's notification, when you pass a list to enum map, it just goes directly to the BIF list.map. So the third one I did was actually my preferred syntax for all of this, which I definitely kept out, which is the Erlang syntax. Does everyone know what a Erlang BIF list comprehension looks like? Here, I think I can just share my screen. Here. Maybe, we're hoping I haven't angered the Zoom gods. Hey, there we go. All right, let's just open up NVim fast. All right, so I just developed I'm swearing, but that's fine. This is what a list comprehension looks like in Erlang. So this is my preferred syntax, and I only realized it because of a conversation I work with Roland, if you're wondering, about Vim recently, which is the reason I like the syntax is because A, it's obviously a list. B, the quantum of work comes first, and that's usually what I'm debugging during list comprehension. And then if you want generators or filters, it comes last. But that's Vim's logic, quantum of work selection. That's why I like it. Whereas the Elixir versions are all whatever, like the thing it's doing is on the tail end, and that's all. And I have a weird vendetta against ampersand syntax, which is entirely a me thing. It has nothing to do with it being good or bad. But yeah, so that's all. It was just an interesting little splunk where I'm just like, oh, all of these are approximately equivalent. They're different BIFs, so there's slight difference in them, but the difference is, well, I can just do it fast. So if you guys are unaware, you should watch Chris's talk, Hitchhiker's Guide to Beam Performance, but I'll spare you me playing with very large lists. All I'm doing here is iterating over a list of the Unix socket. Not the Unix, sorry, Roland got me with this. Unix dictionary. So if I just do mix like run, what is it? Mix run and then samples. And so this is just going to do benchy thing, but it's just pulling up all of the words that Unix is aware of. And it's benching enum slowly, apparently. Probably Zoom is taking up resources. unless I forgot to save, which is
I'm sure it is. It's good at that.
But yeah, it's just benching that takes like lines of code. And this was like 10 minutes of me talking with a friend, and we managed to figure out like, oh, these are all loosely the same. And it's a great way of solving an argument about this dumb kind of a dumb thing like that. Pick your poison. There's no difference really.
The one thing that I like about 4 is you can combine filters, right?
Yes.
Comprehension. And if you use enum map, usually I see developers do enum map, enum filter, and like just like multiple different. And because of that, 4 might be more performant than combination of enum map.
Yeah, if you are doing filters without there's enum map reduce or something, enum filter map filter, which does exist now. But yeah, you're right. Like if you are stringing a huge amount of filters or selections, 4 and the Erlang equivalent are going to be about the same. A lot faster than the enum map because you're not passing.
At the same time, I don't know if Erlang has that in comprehension, but in Elixir 4, you can also pass 4 into, and for example, comprehend into string, like do 4 into string, and you can combine a string, not a list, right? And
Erlang
also,
doesn't have that. It has to be a list at the end, I think.
Yeah, and also there is a 4 reduce, where in some cases 4 reduce might look nicer than enum reduce, but sometimes they are not compatible. Like it's not one-to-one. You can combine them well because 4 has that. When you do that enumeration in 4, you already can filter them right inside that 4. You know, like right inside that pattern matching. You can filter it at the same time. So yeah, that kind of I would say a little bit different. I don't know.
Oh no! In this particular case that we were talking about, you could write the 3 exactly the same. Like it was just it's what syntax. So you're quite right. If you're doing a huge amount of filtering, both 4 and an Erlang list comprehension, assuming you want to list out, will be more performant because it's kind of doing it all in one in the C netherworld of the beam that I tried to never read that code ever. Yeah. Anyway, that's all. It was just a silly. I didn't know that there was a pattern match for list in enum map, and I was like, oh, well, I'm dumb. Never mind.
Always new corners to discover.
What the hell just happened? Huh. Can you hear me okay?
We can. What is with the microphones tonight? All right.
Yeah, no.
We can hear you. You're all right.
So yeah, something just caused. I realized my headphones just did something weird, and my noise cancellation shut off. So I just looked it up. I was like, didn't I like? Because you saw me nodding right about their form and stuff, and I was like, why do I know this? And so apparently back in 2017, I did a beginner's track on list comprehensions, and one of the things I did was benchmark for it, and it is one of the few things that actually got committed to the Denver. Meetup, the Denver meetup repo. So if you want to see how I was, Anton out. Thank you, Anton.
Up so much.
We really appreciate it.
We did.
But yeah, so I just posted a link to the. If you scroll down to the bottom of that, I have no idea. I mean, I have no idea what the lesson was or what I was doing at the time. It looks terrible to me now. But to the point where I even was using Benchy to do benchmarks. So
yeah, that's cool. Actually,
benchmark things. It's fun, you know.
I went for random in old Inata articles on all the weird gushes that happen in Erlang list comprehensions with the way its filtering works. I was just like, oh, how does that even work in the first place? Cool.
Sweet.
All righty. Well, it's the half hour, so I think I'll wrap it up here and unplug